Okay. So, is there anyone new today who didn't attend the course yesterday or first day they missed? So don't worry. We have just started like very basic introduction of like why Docker is needed, sort of thing, uh, and what is Docker and where does it fit in and all. But I will try to just quickly revise them and we'll start it. So before starting, so myself Vijay Sharma, I'm a GCP certified, Google certified GCP architect and Microsoft certified professional, and I have 11 plus years of experience in containerizing workloads, deploying production grade clusters and environments. Okay, so in this course, we are going to learn in depth about Docker and Kubernetes to make you equip you with the necessary understanding so that you can, if you are a fresher, like you can attend the interviews and get the job with confidence. If you are a senior software engineer, then you would get advanced techniques and tools which will help you in growing in your career. So that said, I've already discussed yesterday about the what are the topics we are going to cover in this course and all. If you want to go and visit, the recording will be there in the YouTube for the demos, and we will have one more demo on Monday, and after that, like only the video recordings and PPTs will be shared to the registered participants only. So coming to the presentation, let's start with the session. Uh, we will just try to understand much better scenario what was existing before Docker and why we need Docker. See, let's say you went to interview. So the interviewer asked like, "Hey Hannah, hey Syed, like, why do you need Docker? Okay, why? Without Docker, can't you work?" Then you need to be able to understand what was happening before and why there was a necessity that we should use Docker for our day-to-day SDLC process, software development lifecycle process. For that to understand, let's see what was happening before and then what was happened after the advent of internet microservices based architecture and a set of technologies which cloud a set of technologies such as this, and how the software development lifecycle has become agile. Okay, so let's briefly touch upon some aspects what was happening before. Let me stop and share it again so that we will share the whole screen. One second. Yeah, okay, can you see the paint screen? Yeah, I hope you can see it. Okay, so what was happening before the advent of all these things? Mainly, thanks Karthikeyan for confirming. Okay, mainly what used to happen is that there used to be a single set of code, like mammoth sized code, single block of code called monolithic based architecture. That means a single set of code. And what used to happen? The developers used to be there and they used to develop the code and take some months to push it to the QA, and QA used to perform the necessary testing for the code. And then once the code is tested, if there are any bugs or if there is anything identified, they will then again route the code or mention it to the devs. They will fix it. Sorry, they will fix it, and once this process is completed, they will roll out the release to user acceptance testing, UAT we call it. And once the client is happy and ready to give the necessary billing, they are ready and they will proceed with the end uh, go live or production or whatever word you want to use. You can release it to the end users or the part the actual users. Okay, so this was the process used to happen. What is happening? What is the drawback in this? It looks very good, right? Like people are developing, people are testing, and everything going smooth. But where was the challenge? See, for a code to be completely built and roll out for QA, there is something called the time, effort, and money that that gets consumed when the bugs are discovered in the later point of time in your development life cycle. That means the cost of fixing a bug is very much higher when you one second guys. Guys, are you able to hear me? Guys, can you hear me? Okay. Yes, now. Okay, that means were you not able to hear earlier? Okay, fine. There seems to be some issue with my headset, and yeah, that might have been like some issue. Okay, coming back to our presentation. Okay, got it. I thought like everything was good. Okay, one second. Let me remove my headset. Okay.
Okay, can you hear me now? Is it well? Good. Okay, I'll start from the paint part. Yeah, sure, Sayed. I'll start again. Uh, what was happening? So let me share my screen. Okay. Sorry for whatever disruption that happened. So starting from this, so what used to happen earlier before, like let's say 2005 or before that, okay, before the advent of agile methodology and all, there used to be a bunch of developers and there used to be huge set of code which is called a monolithic code. That means all the code base for an application required will be in a single, single package like war file or jar file. So now, this particular whole file or a whole application used to be built and then it was delivered to QA team for testing. Okay, what QA used to do, they used to test and they used to take like few months for development itself. They used to take like few months, and then QA used to take like so much time to test, and if there are any bugs that were discovered, those will be again assigned to dev for fixing them. Okay, this to and fro, this will happen for few more months, and by the time they are confident that that can be delivered to client, they will give to user acceptance testing, and the client will have a look at it, and it will take some time, and finally when they want to roll out to the public, it would take almost half a year to 1 year. Now this at the face value, this looks good, but uh, when the internet era started, right, uh, competition escalated like anything. Okay, exponentially your competitors were delivering at much faster pace. Smaller organizations are very fast in developing, testing and rolling out. Now the companies thought of, hey guys, we need to think of a new methodology wherein we need to deliver our software much faster than what we are doing now. You cannot sit and test. QA team cannot sit and wait for months till the development team completes. No, that is not the way. So what these beautiful people, they came together in a conference, and they discussed and came up with a new methodology called agile methodology, where split the whole code into set of targeted and measurable chunks of work. That means smaller set of workload. The code base will be like more or less similar, but it will be split into some measurable quantities of work that can be completed within a specific point of time. That point of time we call it as scrums or sprint, and then we take this amount of work and split it into certain tasks called user stories. And there are so many. We are not going to deep into agile methodology, but this type of activity or this type of way of working, what it helped is that now when they want to move to QA, they will not move the entire code. They will just move the code which was built in the previous sprint. Sprint means set of time, like 15 days, 2 weeks. Mostly people go with, like, 2 week sprints, like that. After the 2 week sprint, whatever the work that has been done, then QA will start doing testing on only that part of the work. Okay. Now what used to happen, only that part of the code can be tested much faster. And in the period where QA is testing that, the development for the next set of works called stories will start development. Okay, so like this one will start. So what is the advantage here? The advantage is that the continuous development and continuous testing is happening, and because of this, the amount of time taken to release the software to market becomes, much faster and much easier also. So because of these advancements, now there was one more technology called microservices which came into picture. Yesterday also we discussed, for those who missed it, microservices is nothing but a smaller set of features which can be independently developed and deployed, but it has internal connectivity to other functionalities of the app, so that they all together give a single impression like a single app. For example, um, let me erase this, and I'm not saving these things. If you need them, let me know. Otherwise, I will just don't save this patches of work. They are not very good looking. Okay, if you want, I can just keep them, and if you want any reference. Now, what they thought, like, these genius people, they thought that, hey, we should not go with single set of code. We should have, smaller features independently developed, independently tested, and any upgrade that should happen should be done with a smaller chunks of code, and at a faster pace. So what they came up with, like for example, you are using Amazon or Netflix apps. Okay, so what used to happen, what will happen in the background is that the whole Amazon application, or Flipkart, or Walmart application, or Netflix, whatever the application is, the whole application is not a single set of code. What will happen is that within the code there will be several smaller features called smaller services called microservices, micro front ends for the interface UI part, and APIs for backend logic, and they will be connecting to DB also. So this smaller set of code or smaller services act together, uh, you know um, to give you an impression of a single server. So you won't find, like, you are going into separate microservice. You won't get that feeling when you go to Netflix. But within Netflix there will be menu items, right? Like shows, movies, and new releases, something. Okay, and in Amazon, if you go, there will be product, there will be cart, there will be new releases, there will be offers. So many things are there, but all of them are actually, guys, in the backend there will be different microservices which are loosely coupled. That means loosely coupled in the sense they have a way of getting identified within this framework, but they are independent of each other. So if a bug is discovered, or if I want to update my product microservice, it will not disturb my cart microservice, or it will not disturb my any other microservice, like, user profile or other things. So these microservices, is a revolution, once in a generation sort of revolution that happened in the way we develop software and deliver the develop our software. Now, what in the whole thing, where does Docker and Kubernetes fit in? Okay, now let's understand what was the real problem. There was three challenges when we deliver software to the client, or to the end user. So these challenges are the problem of isolation, the problem of environment, and the problem of speed. These are the three challenges, are the problems we were facing when we didn't have a sort of Docker and Kubernetes. Essentially, let's focus on Docker. So what are these challenges? What is the problem of isolation? What is the problem of environment? What are the problem of speed? So what will happen earlier, right? There used to be big servers and uh, there used to be big rack servers, and in the data centers each company used to manage before the cloud era I'm talking about. Okay, there used to be huge data centers, and they used to procure big rack servers, which are very costly, by the way. Okay, and also they need so much electricity for making it comfortable in an air conditioned room and everything. There used to be experienced professionals like sysadmins, data center admins sitting there monitoring these things. What used to happen is that in order to optimize the type of applications deployed into it, so there people used to be worried, okay, like 15 years back and all, when you have a server and when you want to deploy two applications, if you want to there is always chance that the changes made to one application might impact the other application. There was no strict isolation, or sometimes there used to be spillover effects, okay, that used to happen. So that was the problem when you had this physical servers with multiple applications deploy into a single server. And and why do you want to deploy multiple applications? Because you need to optimize the hardware resources were costly. Okay, so in order to overcome that, people came up with something called virtual machines. Okay, the VMware era. Okay, where you will have a single hardware lying, but you can spin up multiple VMs, where each VM will host one application with its own set of operating system and necessary libraries and everything packed in it. So one VM, one application. That used to be looks good. Okay, but what if you need to manage 100 different types of operating systems and packaging? If I say like one operating system, it includes the patching, necessary management of the OS, and necessary other libraries necessary for that, whether my application suits well for that version of this OS. If upgrade happens, it used to crash. So still there was so much complexity involved in managing the underlying operating systems. So still it is a headache. So what people thought of, no, we should not work like this. We should have a better way of managing our application. Then people thought of innovating in a way. How do we deploy applications in a manner that it should not depend on the underlying operating system at all? Okay, see the vision of people. Okay, so now they have come up with an idea that, okay, I have a hardware, something like a server, rack server with certain amount of CPU, RAM, and hardware, which can be virtualized. That means virtualized in the sense that can be shared. Underlying common infrastructure can be shared across different applications. That should be virtualized. But my applications should use the underlying operating system without any headache of packaging my again operating system with my application. That in VM, what used to happen, in VM you have application, okay, your application sitting there, but there will be an operating system, and within that application operating system you will be running your application, right? Now I don't want to take the headache of operating system. Application should use whatever operating system running on the server, using the hypervisor and other things. Okay, so we don't go into hypervisor and other things, but basically hypervisor is a type of tool which will help in sharing the hardware resources. Just remember that. Okay, now they came up with a way to package the application along with certain dependencies like libraries, but they innovated a mechanism by which the operating system requirements are fulfilled by the server, whatever the operating system running on the host machine in the sense wherever the application is running on the hardware. Okay, hardware are the operating system. Now what they did, they packaged the application, the necessary libraries and necessary packages required for it, but not the operating system. Now what application will do, application will, whenever it wants to run, it will link to the OS which is already existing in the host machine. Now this has several advantage. What are the primary advantage? You all might have remembered, maybe like if you are using your desktop machines and laptops, if you go to like now the boot times are pretty good, and earlier when you use like Windows XP, and then came Windows 7 and Windows 8 and other things, Vistas and all. So when you try to boot your operating system, that is like, wait time is like huge, like almost a minute or so it used to take all the boot time. So that used to happen with VMs also. Even you are using Linux will also have boot time, right? Few seconds, like 10 to 20 seconds it used to take. So now that is eliminated. Application we can spin up in a fraction of seconds, and you can spin up and restart and do much faster pace. And also take this application. Now I let's say I have another VM and another server, and I don't want to run my application in the first server. So what I can do, I'll take this packaged one and take this to the server, and irrespective of the operating system, I will take my packaged application here and run it. What it will do, it will make use of the underlying operating system's kernel. Okay. Now, for that to happen, for this migration to happen, they need a platform that will make sure that operating system independence or isolation is required. So that tool which will help you to package this application and make it run as wherever you want is called Docker. Okay. So Docker is an application, like a platform which will help your application to be packaged and run irrespective of the operating system, whether you are running on Ubuntu or Red Hat or OpenSUSE, or if not Linux, if you're running on Windows. So wherever you are running, right, Docker separates the operating system layer and provide the necessary isolation, and makes the movement of applications or migration of the applications, and make them operating system independent. Okay. Now after this happened, now in the software development life cycle, how the scenario changed, let us discuss. Okay, guys, these are very high level concepts, so just you can revisit the video again if you want to know. For experienced people, like you might have known all these things, but for freshers it might be new to you, but you can visit again. Now because of this innovation called Docker, what was the advantage happened? So now we will have a single virtual machine or a server, but I can separate my applications and package them into individual containers. Okay. That packaged code along with the dependencies is called containers. And I can spin up multiple containers which are independent of each other. So what is the advantage I'm getting, guys? I'm optimally utilizing my resources. I'm developing my code faster. There is isolation, and there are so many advantages that we are facing. So this is the first problem we solved using Docker. That is the problem of isolation and problem of uh, environments. There is one more problem with environments. That is uh, when developers develop their code, they develop in a set of uh, uh, features and configurations in their machine, right? Okay, whether it is Java version or Python version, they develop according to their machine setup. So now when they test it in their local, that used to perform fantastically fine, but when it goes to QA, or when it's deployed into dev environment, then it used to crash. Then developers used to say, hey guys, it works on my machine. If you are testing, this is fault with your machine. So now that blame game used to start. So this works on my machine scenario. That means that developers are testing in the machines and the environments which are compatible to the application, but not compatible for running in other environments. So this problem, in order to overcome that, this problem, like when you develop for one environment and it used to fail in other environments, or when an employee A or when a developer A develops in one environment, it not used to work for employee B when they clone the code and try to set up the basic configuration or basic setup. So and the set of tools and libraries required for a particular project might not be required or might not be suitable for another project. So basically these differences in environments, runtimes, languages, frameworks made to think that we need to have a development methodology wherein our code should be developed independent of environment. So there comes you know uh, uh, complexity, right? If I am developing a website, now where do I run my website, whether it is desktop or whether it is running on production cluster or cloud or mainframe or somewhere in edge device, IoT sensors. Or so if I am developing something like mobiles, okay, when I am running a website, how do I maintain that complexity? How do I make sure that I need not worry about developing 10 versions of my code and deploying one version for each? You know how much complex to manage the release cycle? Imagine you are a DevOps engineer or a developer. You need to configure your code for 10 types of environment: one for desktop, one for app, one for iOS, one for Android, one for mobile, okay, one for mainframe. See the complexity. What if there are there are multiple sets of applications and they have to be configured for multiple sets of environments? The enormous amount of complexity involved in this is like very very, and with each set of complexity there used to rise amount of money, time, energy that has to be invested. Now that software development became very costly affair, okay? So unless smaller companies need something which is less complicated but more versatile, so that it can go and the code or application can go and sit and run on multiple environments without any hiccups. So there comes the hero who would reduce our complexity, that is called containers. Now I would build one set of code that will go that will be packaged with the necessary libraries and to run as a single entity, self-sufficient entity, but can be deployed into different environments without much further complexity. That will save so much amount of development time, troubleshooting time, sorry, QA time, and then if there are any bugs discovered, troubleshooting time. So this particular methodology of packaging has solved a problem called the challenge of environment diversity or complexity. So this is the main thing. And finally, there is another problem called problem of speed. That is, whenever we develop applications, we need to develop them at much faster days because we are at a cutthroat competition era. So now we need to develop, test, and release them into the market at much faster pace, which is not possible with the monolithic application, because monolithic applications are a single set of code, and like if something happens, or if you want to develop and test it, it is not easier to develop them at a faster place. So the advent of multiple revolutions like microservices based revolution, and then Docker and cloud based and VMs and all these came together by the mid 2000s, like maybe 2005 and between 10. All this came together: the internet revolution, the bandwidth, higher bandwidth, and then enormous pitch for sharing, like shared services like cloud and whatnot. So all the and also the computational costs and building the servers and all these things helped evolve evolve the software development life cycle into like one release per quarter. Like one version of the application used to be released per one quarter, or some one half yearly releases, to nightly releases. That means for every week or every half a month, 15 days, 2 weeks, there used to be a release. Now that is even came down to, sometimes, bi-weekly releases, and some organizations focus on daily releases also. But that is how, these all technologies include and enabled by Docker has enabled faster release cycle and faster deployment to our environments and markets. So this is the fundamental problem solved by Docker, and helped in, much reducing the costs, increasing the productivity of developers, and hardware resource utilization. You know what? When you use VMs, right, are the earlier rack servers and all. So what used to happen? The resource utilization was at max best to 30%, okay, or even less than that. Now the utilization is max, is taken to maximum 70% or 80%, and the rest of thing is kept for scaling and other needs. So now, optimal utilization of resources is leading to cost, reduction also. So maintenance costs are also reduced, and 50% increase in speed of build, test, deploy cycles. So this was achieved because of Docker and packaging and, containerization. Now, when I use these words like containers, Docker images and all, you might get confused. So let us understand what are those terminologies. And before that, any doubts are there? Any queries you have? Let me know in the chat. Are there any queries? Are we good? Can we proceed with the rest of the understanding the Docker terminologies? What is a container? What is a image? What is the environment? Where do we deploy, build, test, and deploy environment? Okay. So, okay, good. If you have any doubt, put it in the chat. I'll answer those questions. So coming back to our this thing, the terminologies which we use for Docker, there is a cycle called build, test, and deploy cycle. Okay, 1 second. Yeah, this build, test, deploy cycle. When I use the words, there is three things here: the build part, the test part, and the deploy part. Now, who builds it? Developer builds it. Okay. Where they build it? In their local machines, using some IDE like, Eclipse or Visual Studio, VS Code or something, based on their application. Now, when they build it, they need to find a way uh, to uh, to package them, right? Now, what I said, Docker as a tool enables packaging of applications along with the libraries. So now this packaging of application is called image. Okay, an image is a template. What developers are, what DevOps engineers are, we are going to learn how to do that. What we do is that we write a set of instructions. Okay, we tell Docker is a tool which use imperative way of commands. Imperative or descriptive. There are two types of way we write code. Okay, in in Docker and Kubernetes and most of the DevOps tools, we write imperative commands. Okay, so what does imperative means? It means that the the we will say, or we will convey the end state we want. The tool has the responsibility to understand the command and deconstruct the command, make sure that that particular end goal is achieved. For example, if I say take image, base image is as Ubuntu or something. Okay, when I run a command or something, as take a command or run this thing or copy from code, something commands like that. Okay, it is it is imperative. That means these are imperative commands. That means that Docker will understand and fetch the necessary image from where the Docker hub or wherever it is located. All the steps involved, like connecting to Docker, connecting to place where that Ubuntu is located, Ubuntu base image. I'll explain all this complexity. Or copy. When we do in a Linux, or what do we do? Copy command. CP. We write the whole command, right? CP, source and destination. We do that, right? So that command will be done by the Docker itself. So we say that, you give me the end result. It is your headache to whatever the steps involved in uh, achieving the end result is up to you. Okay, so this is called imperative way. There is another way, descriptive. Descriptive means writing the whole code step by step, so that uh, like Python, or like our high level languages, or our programming languages, how they work in the descriptive way. You need to write step by step commands or the logic to be executed. But these tools, mostly our DevOps tools like Docker and Kubernetes, are imperative tools, which will have that intelligence to deconstruct and execute those commands internally to achieve a desired state. So in interview, when you get a question, uh, what type of what is this imperative way of writing, or imperative development, then you need to mention that imperative way of development means you mention the end state, or you mention the task that need to be required to be done, and the necessary sub commands and the steps that need to be taken will be uh, understand or implied, or it's understood by the underlying tool or something. In the descriptive way, you need to mention all the steps included. It is clear, guys? Now, the developer who is build in the build phase, okay, in the build phase, what they will do, they will package the application using a set of tools called Docker file. We will see, this is the only second class. We will go at length about what is a Docker file, how do we build it, how do we write it, each command required for a Docker file, how to use it, everything we will learn at in depth. Okay, so Docker file with D capital is a file which is a set of instructions Docker will understand. Now Docker, in this using this file, what we are essentially doing is take the code from my local and package it with my dependencies, and package them into a particular image. Now image is a package or a blueprint that will tell that will have the necessary code and the necessary libraries and dependencies packaged together. Now this image is a static one. Okay, understand what do I mean by static? Static means it will not be running as of now. This image has to be kept somewhere for deploying into my machines. So for that purpose, for testing, right? For example, QA is there. QA will have their own machines. In order to test my packages, there should be a common place where we keep our code. For example, GitHub. What do we do with GitHub? It's a source code management tool, right? We push our code, keep it in GitHub repositories, and whoever want, they will clone the repo, and then they will do it and do the necessary modifications, or they will push the code back after modifications. So what GitHub is doing it is essentially storing it. Similarly, there in the deployment phase, that means in the deploy, we will use something called Docker. One second, it's a deploy stage. And in the deploy stage, we will save these images in a place called registry. Okay. What is a registry? Registry is a place where the images, Docker images are kept. So for Docker, we have Docker Hub as a open source registry. Um, and we have multiple such registries. For every cloud provider, they have their own registries. For Amazon, they have ECR. For Azure, they have ACR, Azure Container Registry. Uh, in Amazon, they have Elastic Container Registry. In GKE, they have GCR, or to be very precise, they have upgraded their GCR to AR, artifact registry. We don't want to go into cloud based, but now a image registry is a place in cloud or in local where the images are kept. Now, once they are uploaded, or we call in our terminology push. Okay, push the images to the registry and the image will be kept there. Okay. Now, the QA team or the DevOps team who is running the development environment want to deploy this built application by developer into development environment or the testing environment and test it. In the test phase, okay, what will happen in the test phase? Okay, this application which is packaged as image will be pulled. Oh, sorry, pulled. That means it is copied into local of this, into the local place of this machine where again Docker is running. Underlying Docker will be there. Okay, please understand, Docker acts as a platform. Okay, so Docker will be there. Now this pulled image will be there, but the for running it, image, what did I say? Image is a static one. So this particular pulled image, a copy of this image will be made and it will be run. The application will be run from this image. So this pinned up copy of the image is called container. Okay. A container is a runtime copy of the application which is spinned up from our image. Now let's say you are a civil engineer or an architect. Okay, when someone approaches you to build a complex apartment complex or a set of houses, then what do? You plan it. You create a blueprint for individual houses, and now it's the headache of the builder to take that blueprint and build the replicas of houses, right? Now, imagine the same methodology. The image is a blueprint. Now, a running replica of a image, that means the application along with the code running in my environment is called a container. Okay. A container is the running copy of the application. Image is the static packaged version of the application. So in interview, when the interviewer asks you, what is the difference between an image and a container? Then you need to answer that, hey, image is a packaged, it's like a blueprint. It's a package. It's the application along with the dependencies packaged into a static blueprint. Now, when that application which is packaged runs on a platform in as a running copy of the application, that running copy is called a container. Okay, this is what you need to understand. It's like image is a class and yes, absolutely right. Um, um, and but the slight difference, you won't be passing any parameters as such, but you can pass parameters here also. I'll discuss about how do we pass the environmental variables and other parameters later. Who is responsible for spinning up? Now, in for Abdul's question, for Vijay's question, like it's like image is class. Yes, correct. That is the analogy is similar. Okay. Now, who is responsible for spinning up? Now, the responsibility of spinning up the containers. That means here in the test phase, whoever is spinning up, either DevOps engineers will spin up, or if developers are managing the development environment, they have to spin up. For all this to happen, they should install Docker. Installing Docker is the prerequisite mandatory requirement that mostly Linux admins and DevOps engineers will do. Yesterday, someone was asking, as a Linux admin, should I learn Docker? Yes, it is a very it is an important tool to learn Docker so that you can facilitate your containerized applications running in your Linux environments. Okay, without knowing Docker, how do you understand which version of Docker to install? You won't know, right? Like, and how do you troubleshoot if you have any issues with Docker? So it is very important for either you are a developer, or you are a DevOps engineer, or you are a solutions architect, or you are a Linux admin, or you are a software enthusiastic. Docker and Kubernetes is going to help you in a in a in a in a in a long way. Going several years to come, these technologies are going to stay. So I urge you to register in this course to learn in depth about this course. Okay. So coming back, who will spin up? The responsibility of spinning up the containers lies with whoever owns the environment or whoever manages the environment. Mostly DevOps engineers or Linux admins will help developers to pull the images from registry and spin up the containers. So now spin up means creating the container from the image. So there are certain commands that we will use, and there are the way we will pull the images and all. Now, uh, for quick way of understanding this, not tomorrow, tomorrow is Saturday, right? The last demo session or the Monday session, we will understand how to install Docker and how to work with Docker. But till then, I have a surprise for you. You don't need to install to test or run and learn hands-on how to work with Docker. There is a beautiful playground in online to work with Docker. Okay, so that is called Docker Playground, and I will share with you one such playground that will help you in uh, 1 second. Uh, 1 second. There is a playground. What is a playground? Playground is like a sandbox. Okay, I have paused the screen share. Just hold on for a minute. Uh, I'll give you the playground name. Okay, Docker Playground. What playground will help is that you don't need to worry about installing the Docker and worrying about how to install Docker and where to install and other things. But it is essential when you go forward in the course, you need to know and you need to install Docker somewhere and work it. I strongly recommend going forward you install after I explain how to install in different machines like desktop and Linux. You install them, and because in real world you will be doing it, you won't be using Playground. But today, uh, for the weekend, for fun part, go to this labs.playwithdocker.com and work with Docker hands-on to see how the Docker commands will work. I'm putting it in the chat. You know, oops, okay. Uh, okay. Okay, go to, there are few questions. I will take that in the end. So now go to this link, labs.playwithdocker.com. And what you need to do, you need to log in. You need to log into Docker with either federated identity, like you can use your own, Google based authentication. I have already logged in using my Gmail ID. You can also register with using your Gmail ID, or you can create your own Docker account. But you need to just click on start. Now what happens is that once you register and click on this is a free one, by the way, you need not pay anything. This particular playground will be given to you free of cost to learn and work with Docker. Okay, so beautiful concept of playground, where you need to spin, you can create a new instance means one virtual environment. Okay, this virtual environment will help you in running your Docker commands. Okay. So for example, let me give you a homework. Okay. Now in the weekend, try to log into this playground and 1 second, alt enter, right? Okay. 1 second. Now I'm just looking to make it full screen. Okay. Control. 1 second. Terminal full screen. Alt enter. Okay. Just enter. Okay. Now, yeah, this particular instance, let's say this is a virtual machine running like your local or a VM, Ubuntu or something. Now, run some commands and try to spin up certain containers and test few commands. Like for example, I want to know what is the version of Docker I'm running. Okay, the command will be docker-v. Okay, now the Docker version is this, build is this. Now Docker, run this command, docker hyphen help. Okay, now it will, 1 second, small, sorry, docker hyphen hench. Now all the help commands are there. Now see this command, try to run, try to see how each command is working. One I want to suggest you one important tool to become a expert in DevOps tools. The only way is to make your hands dirty. That means you need to work, you need to try, experiment. What at best what will happen, it will throw an error, right? Go to Google, search for that. In Stack Overflow there are like there are many forums out there to help you with your, and you can go to, of course, Gemini AI is there, ChatGPT is there. Now they are like your personal assistant to help you with learning these tools, right? Now use these commands and try to you know spin up the containers and test it. Okay, so this is the homework for you guys. So in this live course, the advantage is that I'm going to give you certain homeworks. I'm going to give you labs. I'm going to give you interview questions. And this course is a package of all the things that is required, whether you are going to get a job or you are going to get certified like CKA, get certification, or you want to learn for your upskilling. This course is going to cater to your needs. So my humble request is go ahead and register for this course to get full benefit from this course. Okay, because the PPTs and every recordings and extra resources I'm going to provide you will only be shared with the registered participants. So my humble request is go get registered and get full use of this course. So coming back, let's see Docker, some commands, Docker run. I want to run a, Ubuntu or something. Ubuntu, one second. Ubuntu. I want to run this, a copy of Ubuntu in my thing, and I will pass a command called -d in a detached mode. I will explain you why detached mode and all in future classes. And I can use a certain port combination like 8080 and with 80. I will explain you why we are passing this and all. Okay. Now what is happening? See, now my Ubuntu is trying to pull, and now it has pulled a newer image called Ubuntu latest. But what it is what it is saying, it has error response from daemon, says that it has failed to pull the container because the port -p is not found. The path is not found or port is not found. So we will troubleshoot it by passing some more commands. Okay, like Docker. So in order to test, we can use a smaller thing instead of Ubuntu. Docker run, fn2, httpd, and I will pass the port, different port, okay? 888, and we will go to map it to 80, something like that, okay? Okay. Now, what I'm doing, whenever I want to run an application, right, it will take that application, whatever image I want to run. This command, run command, what it will do, it will take the image from the Docker registry, and it will try to spin up a container from an image. See, create and run a new container from an image. Okay, that's what happening here. Okay, so similarly, we will see like the port has any issues or something. Okay, so basically, when we run this, what is essentially happens is that this part is happening from registry. The image is pulled, and it will deploy the save the image and spins up a container. So in order to see if the container is running fine or something, we will see. We will go back to here. 1 second. We'll remove the port mapping for now, and let's see. Docker ps, it will show that my httpd is image, and a container has been created. And every time container is created, it will take a random name. If we don't pass a name, we can pass a name and all. So these all in depth we will see, all these things in future. So don't worry about all those things. So curl -v http localhost, 1 second, Okay. Okay, fine. We will try to debug it in the further sessions. So basically, what we want to do is try to pull one image like HTTP, or Tomcat, or Ubuntu, or some server, some image from the registry, and deploy it in your local machine. This we were trying to test and simulate. Okay. So in the weekend, you go to this playground, try to test few commands like docker run and docker things, and try to test few commands. Okay. So this is what we want to uh, test it. Okay. Like you can run this command, this sec port. Okay. Okay. Fail to create as unable to control process port executable file command. Okay, fine. There is a issue with small command passing, and all we will see it. Okay, so we will not worry about that. But essentially, the goal is that you need to learn how to use the help commands. Okay, you need to pass it docker -h. Hi, admin team. I have paid the complete. Hey, Krishna, I'll just come to you 1 minute, Krishna. Okay. Uh, Now, you have seen that this is the Docker playground, and you can go here, create one more instance, and use the another instance for running as I'll explain the Docker architecture like Docker CLI, Docker engine, and Docker client, like that. Okay, so I will explain the architecture in the next session, and we can work with multiple instances here. Okay, going forward, we will create a VM and run the Docker there. We will not be using playground, but for the initial days, please use this playground till the installation session happens. How to install and all, I will provide you the thing. So this is for today. uh, Coming back to the session, what we discussed, let's summarize. Okay, today we have discussed what is the problem that Docker is solving. It solves the problem of isolation by by creating individual environments. It solves the problem of works on my machine issue, that is problem of environments. It will resolve like build once and deploy anywhere issue. It will solve the problem of matrix of complexity, and then it solves the problem of speed. And because of this, we are getting all the benefits like develop faster, building faster, testing faster, and update faster. And if there are any bugs, then we can recover and fix them faster. Because of this, we can have achieve build, test, deploy cycles in at much faster rate. We can save the cost and everything. So because of this, we can these are the results we will get. So so this is for today's session. In the next session, we will learn about architectural components, and we'll spin up some containers, and we will try to learn Docker commands and other aspects. So uh, thank you for being patient, and we have a offer for you. Whoever is going to join this course, right, we are going to offer you as a bonus, as a gratitude for joining and registering with this course. We are going to offer you the Prometheus and Grafana monitoring tools absolutely free of cost with this course. So you can log into LMS, and once you register, you will see this course, or you can connect with our support team to get access once you register. And also, I'm going to provide you resume samples, how to put it in your resume, how that you can showcase your experience with Docker and Kubernetes. So I can provide you, I will provide you sample resumes so that you can copy that into your resume and incorporate into your resume. I'll providing a real-time project which you can showcase to the interviewers and prospective employers. Then I will provide you certification dumps for CKA and AZ. 104 and other exams, so that you can clear them with your DevOps knowledge. So CKA and other things will have some extra topics also. So the relevant topics for this course will be covered. So I will be providing you constantly interview tips and techniques and other things. And whenever some advancements happens, I will be adding to the course. Okay, so you will get all the things. So this is from my side. So please register. Go to logslabtechnologies.com, or if you have any issues, then drop a mail to support@logicslabtech.com. I'm putting the in the chat. How many project you are going to cover? One end-to-end project we will cover for the whole thing. Okay, that will be sufficient for you to understand the end-to-end. See, each lab is a different thing. I'm talking about project. Okay, labs are individual set of functionalities to demonstrate one particular feature. For example, how to deploy Ubuntu environment. It is a lab, but how to set up end-to-end production grade environment using Docker and Kubernetes. This is a project. So one real-time project will be given that will be exactly similar to how we deploy setup in our version. What version of Kubernetes we will be using? We will be using stable version 1.28, 0.5 or 28.9. 1.29.2 has some issues, but still it is a wrap. See, there are release channels and all, but we will be using stable version of Kubernetes, which is supported by the cloud version. For example, EKS we'll be using. EKS in the sense Amazon Elastic Kubernetes Services. So whatever the stable release EKS supports, we will use that version. If your question is about which cloud provider, mostly we will go with EKS for our understanding. But for the friends out there who are from Azure and Google GCP background, we will be demonstrating how to set up AKS and GKE clusters also. Now, these are the WhatsApp group. Please join this WhatsApp group for all the informations. And okay, is it help to clear the interview? Yes, if the interview about DevOps position, this knowledge we are going to provide you for Docker and Kubernetes is going to immensely help you to clear your understanding. Okay. Yes, Pankaj. Sandeep Verma, will be learning Docker Swarm and Kubernetes. Are we going to use kubeadm for self-managed Kubernetes cluster? kubeadm we will be demonstrating for one class, but that is for just to enable you to understand what involves in setting up in a bare metal Kubernetes. But most of today, people are expecting cloud-based knowledge. So we will be mostly working on managed Kubernetes. Okay, but I will show you one class will be dedicated for kubeadm-based installation and self-managed. Yes, yes, definitely we will cover clusters and things. That was right. For those who have missed yesterday's session, I will show you one more time. You go to this logiclabtechnologies.com and get the go to the course contents. Okay, let me 1 second. I'll also share with you the course content link also. Just wait for a minute. Okay. Now, the course content will be there. Where is the course content link? It will be there somewhere. Okay, when you go to logiclabtechnologies.com, 1 second. Logic Labs Technologies. You go here in the courses, search for Docker and Kubernetes. Docker and Kubernetes, click on it. In the Docker and Kubernetes, about the course, you scroll down, there will be course content. Click on it to download the course content and go through it. So essentially, we are going to cover from scratch to in-depth explanation of Docker, including Docker advanced concepts also, and Kubernetes, both managed and classical Kubernetes. Okay. We will be focusing more on managed Kubernetes. I will be straightforward with you because the expectation from job market is more into how do you manage the complexity of managed Kubernetes. Although certain expectation will be there. So for that purpose, I will be covering kubeadm based contents also. Pankaj, right? Yeah. Coming back to the questions here there, regarding Krishna's question, Krishna, did you try to connect with? Okay, guys. For now, we have ended the session. Today, the second demo. We will have the next session on Monday. That will be the last demo. And after that, there will be no free demos and only registered participants who can be able to log in. Okay. So thank you so much. See you again on Monday. And please try to register and get full advantage. So now I'll address some questions. Those who want to, I will be stopping the recording. Those who want to drop, you can drop. You don't have any questions. That's super. I'm stop the recording.